Okay. Uh, can you tell me the difference between inheritance and composition in Java?
Yeah, the purpose of inheritance and composition are same. The code reusability. So, so both are the fundamental concepts of object-oriented programming in Java. So basically, in inheritance, we write one class, and there can be another class which extends the parent class. So this is what we say inheritance. So we use extends keyword in the child class, and so it's like suppose we have parent class and we have a child class. So we say class child extends parent. So basically this inheritance represents each a relationship, and the composition is a has a relationship. So let's say we have a class engine, and we have another class car. So we can include engine class as a member variable and in the car class. So we can use inside the car class. So yeah, this is the basic difference between these two.
Okay, can you tell me when to use abstract class and when to use interface?
So the abstract class can have both abstract methods and concrete methods as well. So the abstract method means the method without implementation, and concrete method means with
Okay,
implementation.
that's fine. So can you please tell me when to use abstract class and when to use interface, like scenarios?
Scenarios like so for interfaces, we use when we want to define a contract that multiple classes can implement, right? So suppose we have the multiple interfaces, and one interface has suppose several methods, and another interface again have several methods, and we want to use all of these, right? So we can have a class, and that class can implement both of these interfaces, but the same is not possible in case of abstract class. So when we are going to use the extend the abstract class basically, so in that case only one abstract class we can use extend, right? But in case of interface, we can have multiple interface implemented. So basically, if we want to achieve 100% abstraction, then we go for interface. But suppose if we want to achieve partial abstraction, then we go for abstract classes.
Okay, so as you said that using interface you can achieve 100% abstraction. Is this still true when keeping in mind Java 8? Have you worked on Java 8?
Yeah, I have worked on Java 8. So yeah, you were right. So the we cannot achieve 100% abstraction after Java 8 or later. So if it is a functional interface, then yeah, so it will have the default and static methods with implementation. So they can have. So yeah, we can say that we cannot achieve in this case 100% abstraction.
Okay, so you were saying that now 100% abstraction is not possible, right?
No, so in Java 8 and later interfaces can include default and static methods, but we can still achieve 100% abstraction by defining only abstract methods and avoiding default and static methods. So it's not mandatory to include default and static methods in functional interfaces. So this allows interfaces to specify a complete like contract for implementing classes without providing any implementation details. So yeah, we can still achieve it.
Okay, what are the other features you are aware of in Java 8?
Yeah, there are various features like Lambda expression is there, and stream API is there, functional interface, which already I told, and then inside functional interface we have default static methods, and optional class is there, and date time API. So yeah, these are the things I'm aware of.
Okay, so do you know parallel stream?
Yeah, parallel stream in Java it basically is the way to um, process the data in parallel. So suppose we have a huge data set and we want to process it in a faster way, and we have suppose the system on which we are doing this processing has multi cores. So we can split the cores, and parallel stream can be performed. So this is basically useful for large data sets or computational intensive operations. So for this there is a method called parallel stream. So that method can be used to perform the parallel stream operation. And also while applying this we should be careful, like um, so the data, suppose the computation, if we want to do uh, is sequential, right? So in the order how it has been given, in the same order, suppose if we want to perform it, then we should not use parallel stream. So parallel stream can only be useful when the sequence does not matter. So yeah.
Okay, so how do you handle exceptions in your project?
So exception is like any abnormal behavior which happens while program execution. So suppose any file is there, and we are trying to read it, and at the specified location that file is not there. So it will throw file not found exception. So this is like one example. So this exception can be of two types. So one is the runtime exception and one is compile time exception. So the compile time exception is something which developer need to handle while he or she is writing the code. So whatever, suppose ID the developer is using, let's say Eclipse is using, and if you have any compile time error, it automatically shows. You can see there is a red mark, and you need to handle that. So this thing we can be done normally in the catch block. So in the catch block we catch that exception, and there we can either print it or like we can log it. Maybe if you're using log4j or any other logging tool, then we can use that tool and we can log it, log.error, and then we can see those logs in the error if anything wrong happens. So now coming to runtime exception. So exception basically happens as its name suggests at runtime. So suppose there is something wrong with the logic. So let's say divide by zero, right? So any expression is there and we are dividing their number by zero. So at the runtime it will throw the error. So it will throw the arithmetic exception, and again we also some many times we get null pointer exception. So suppose any object itself is null, and that object dot whatever its get property we have written anywhere, so it will throw the null pointer exception. So generally we don't handle this, so developer does not need to handle it, and it occurs at the runtime only. And also in Spring Boot, we have a annotation at the rate of controller advice. So that is the centralized way of handling exception. So we use that in case of Spring Boot.
Okay, so with try catch, we also have a keyword called finally, right? So can you explain me about this?
Yeah, so finally, in finally block, so no matter, I mean, what happens with a try catch, if catch is also not there or anything, I mean, any code is executed, but it definitely comes to the finally block always, right? So normally in the finally block, we use the, suppose any connections has to be closed, which we have opened in the try block, try block. So we do that in finally block. So there is a scenario like whenever we say system.exit. So in that case only finally will not execute. Otherwise we use finally for, so for all the cleanup activities, for example closing connections, releasing files. So in those scenarios we use finally. Yeah.
Okay, so what is the difference between link the hash set and reset?
Linked has set and reset. So linked hash set basically maintains the insertion order, and tree sets, I think that we use for the, I mean, any, suppose we have the scenario like we have to sort the elements. So in that case we go for the tree set. And suppose we have the scenario like we have to maintain the insertion order of the elements. So in that case, I think we should go for the linked hash set.
Okay, can you tell me the difference between double equal to and equals method in string?
Okay, so double equal to compares the references of two objects. I mean, it just checks whether the two um, uh, references point to the same memory location. And equals method, dot equals method of a string, it basically compares the actual content of the two objects. So suppose we have a object of a string in which, let's say, any content is written, let's say xyz, and we have again another string object using new string of, then in double quotes we have xyz. So although the values are same for these two, but actual memory location is different for both of the strings, right? So when we say like the s1 equal to s2, so s1 was the first one and s2 was the second one. So in that case, since both are pointing to different memory location, so it will be false in case of double equal to. When it is when it is s1 equals s2, in that case, since the content is same, so it will return true.
Okay, so in Java 8, do you know what are the methods which has been introduced in a string class?
Yeah, there are some methods has been introduced in Java 8. One I remember is strip method, I think. So which basically removes the, I mean, white spaces from before and after of the string. And then again we have strip leading and strip trailing. So leading means removes leading white space, I mean at the beginning of the string, and in strip trailing it removes from the uh, uh, end of the string. Then another one is I think blank is blank. So basically, it checks if a string is empty or contains any contains only white spaces. So in that case, we use is blank. Then we have string. I think join method is there. So in this, basically, we can give the multiple words we can give, and it joins that to the string. Then I think lines is there. So uh, yeah, so these are the ones which I can remember right now. Okay, what is immutable class? And suppose if you want to create your own custom immutable class, so how will you create it? Okay, so custom immutable class ensures that the class cannot be modified after its creation. So, for example, we have a string which comes, out of the box for Java. So, to achieve immutability, we follow few rules. Um, so, so the first step is we declare the class as final, and after that we make all fields as private and final within that class, and then next we provide a constructor to initialize all fields, and then we do not provide the setter method. So we will have the getter method, but we do not provide setter method, so that no one should be able to set it and update the object. Okay. So yeah, so these are the steps I think we can follow to create an immutable class or custom immutable class.
Okay, can you explain me what is Eureka in microservice architecture and why it is used?
Basically, Eureka is a tool, we can say, in microservice architecture for service discovery. So basically, we have the um, Eureka server where all the microservices register themselves to that server. So basically, the idea is that all the services which are the part of the application, so they all register themselves to the Eureka server, so that any point of time, if suppose any service is calling another service, so it does not call it directly. Instead, it goes through the Eureka server. It goes to the Eureka server and finds out the location of the uh, Eureka service which it wants to communicate. So basically, it's a part of Spring Cloud Netflix, and it helps microservices find and communicate with each other without hard coding their network locations. So suppose we have an e-commerce application with different services for, let's say, user management is there, and some inventory is there, orders are there, and payments are there. So suppose these are the services. So each service might have multiple instances running again. Okay, so in this case, Eureka helps us, uh, helps these services to discover each other easily. So, for example, the order service, suppose it can find the inventory service without knowing its exact location. So it does not has to reveal it IP address and port and the service names. The complete URL. So instead, it should go via Eureka server. So yeah, that is how Eureka is used. Yeah.
Okay, so what are the various ways how communication happens between microservices?
Yeah, so the communication between microservices can happen either synchronously or asynchronously. So it can happen using these two ways. So synchronous call basically means that as soon as any microservice calls another microservice, so it basically waits for the response, and as soon as it receives the response, then only it moves ahead for the next task. But it does not happen that way in case of the asynchronous communication. So in that case, basically, what happens is, uh, so we have active some message broker like ftmq. So so the microservice sends the message to the message broker. So and it just moves on. So it does not wait for the response. So this is what is the major difference between these two. So so this is what the synchronous and asynchronous call microservices.
Okay, so earlier you explained me about Eureka, right? And you said like Eureka is the one through which the communication happens, right? So where is the Eureka stands in this? In your explanation, where you explained about asynchronous and synchronous calls. So where is the Eureka in this? Can you explain?
Yeah, Eureka is also involved in this. So suppose any service is calling, trying to call the another service, so it just goes to the Eureka server, and basically it kind of it asks, okay, so where is the service? So Eureka responds back like suppose the another service is at some IP address, so it gives that IP address, and then further that service which is trying to call the another service, so it directly calls to that IP address, and in case of synchronous, it waits for the response. But all this flow happens through the Eureka itself. So that is how it happens. And again, in case of the asynchronous communication, so same thing happens. So the microservice A tries to communicate first, calls to Eureka server, and there it asks, okay, I am looking for, let's say, any other uh, microservice IP address. So Eureka provides that IP address, and then this microservice again further directly sends the message to the message broker for that specific IP address, and it just moves on. So it does not wait. So I mean, this is how it happens. So we definitely have the Eureka involved here. So yeah, that is how it happens.
Okay, how do you handle fault tolerance in your microservices?
Okay, so fault tolerance is basically the ability of the microservices to make the all the services running even if the any of the microservices is down or slow or not responding or something. So in any case it should not break down, or there should not be any cascading effect. Cascading effect basically means like suppose a microservices A calls B and B calls C, C calls D. So and suppose it breaks while A is making call to B. So obviously, so all the calls will simultaneously fail. So we don't want this to happen. So to prevent this, we have some concepts to apply. So we use Hystrix or Resilience 4J. So there's a library Resilience 4J. So that we use in order to prevent any failure. So basically we write a fallback method. So as soon as any issue happens, and suppose we are trying to make the call to another service, and if it is not responding, then we write a fallback method, and in that fallback method sometimes we hard code it, like maybe some services down or something as per the business requirement, and then further we continue our services, so we don't show it as a down. So we have some other ways also to prevent this. So we also have the multiple instances and or components, so that if one fails then other can immediately take over. So So the load balancer can redirect the traffic to the other instances in case of this kind of situation happens. And also like we also write the something like retry logic, so automatically retrying the failed operations after a certain interval to handle the issue. So basically whenever any call fails, still it will be keep on retrying for few times before completely making it down. So I mean, uh, so all this basically depends on the business requirements and the situation where we are doing this. Yeah, so yeah.
Okay, so is there any way to monitor all these microservices when it is down or when it is failed in very advance?
Yeah, there can be various ways. So we have the some health check tools are there, like actuator is there, Spring Boot actuator is there. So we can use that and we can continuously check the health of the application. So it will tell. And also we have like centralized logging system as well. So like Kibana and all is there, so that we can use for there is a dashboard. So Kibana dashboard can visualize log data trends and alert on unusual patterns, so if any issue is there. And we also have Zipkin, so that traces the request across services to identify performance bottlenecks.
Okay. What difference you see between Spring and Spring Boot while implementing dependency injection?
Okay, dependency injection. The core concept is same uh, for the implementation of dependency injection, but in Spring framework we used to do like it could have been XML based configuration or it could have been the Java based configuration. So for XML based configuration we used to write in the XML like kind of bean ID equal to the, let's say, the bean name, and then the class equal to the whole path of the class, right? And similarly for Java based configuration we used to write at configuration annotation, but in Spring Boot we normally don't write these. So basically in Spring Boot reduces the need for boilerplate configurations. So it provides auto configuration and some different types of starter dependencies. So like we have to only focus on the code and logic. We don't have to focus on configuration, like how we have to configure it in order to use it. So yeah, this is the difference I see between the Spring and Spring Boot.
Okay. So how do you test your application in case of Spring Boot microservices?
So to test in case of microservices, in each suppose we have Spring Boot application uh, for each microservice. So what we do is we first of all with every Spring Boot application we perform the unit testing first. So that unit testing can be done using JUnit or Mockito, and then we do the JUnit testing is done, then we perform the integration testing. So in this case we test the interactions between multiple components. We ensure that they work together as expected. Then suppose any interaction with database is there, so that also testing we do. So I think we have one annotation at the rate of data JPA test. So we use that for these kind of testing. Then we have something called contract testing. So to ensure that microservices can communicate with each other correctly based on the predefined contracts. So for this we use Spring Cloud Contract, and then we further do end-to-end testing. So that part normally testers do. So they use Selenium and other tools to perform this testing. So we don't do normally this one. And then again further they do performance testing. So all these normally testers do. So I don't involve in this. So yeah, these are the ways we perform the testing.
Okay, have you worked on NoSQL?
NoSQL, yeah, I have worked on MongoDB.
Okay, can you tell me how do you integrate this with the Spring Boot application? Suppose you have to use MongoDB. So how do you integrate that?
So for MongoDB, first of all, we need to add the dependency. Suppose we have a Maven project, so in dependencies we add for the MongoDB, like something like a Spring Boot starter, MongoDB, something like that. Then we configure the connection in application.properties or YAML file, like whatever the host name, port, so all that we configure there. So apart from that, we also configure the corresponding database username, password. Then we create a model class. So like we have in relational database, we use at the rate of table, but in this case we use at the rate of document. So we define the model class to represent the documents in the MongoDB collection. So for that we use at the rate of document annotation, uh, and under that we name the collection name, and then I mean inside this uh, model class we give whatever ID is there. So on top of that we put at the rate of ID, and for other properties, for all the properties we create getters and setters, right? So after that again we write a repository class, sorry, interface, not class. So that interface basically extends Mongo repository, and then there we can use Spring Data JPA, and then we can have, uh, let's say if it is some email ID is there, so find by email ID, and delete by ID. So all those methods we can write in this, and then this repository can be further called by the service class. So this is same how we write in case of relational database. So same at the rate of service we write, and that whatever the repository we had, that we inject here using at the rate of auto add, and then again we write the REST controller, how we write in case of uh, relational database, using add REST controller and add request mapping and all that. And if from here again we call the service, so like from controller we call the service, then service calls the repository, and repository fetches the data from the MongoDB. So yeah, so this is what the complete flow we I mean we perform.
Okay, what is Spring JPA Hibernate DDL property? Do you know about this?
Yeah, I mean this is used for the uh, when we want to create the database, or uh, drop database or update database. So in that case we use it. So it has some uh, uh, properties like update, create, drop, validate. So yeah. So whenever we have create, so it will create the database, and whenever we have update, in that case it will update. Create drop will drop, and then it will create, and validate will validate.